Hello students, see today I am going to discuss about the previous year question paper chapter name as D and F block elements, the 2015 to 2020 question paper. See, in this lesson you have to more concentrate the reasoning type questions and complete the equations similar to the P block elements, then the calculation of the spin magnetic moments, that is mu is equal to n into that is root of n into n plus 2 formula, using that formula. Then after that account for the following types questions. Then the data are given from that table. You have to choose the correct answer. That types of questions will come. So more concentration of this topic, you will get a more mark in this lesson. Now we will discuss the question and answer in this lesson. Hello students. Today I am going to discuss about the D and F block element, the previous year question and answer, that is previous year paper is 2015 to 2020 question and answers question paper. See, in this lesson you have to mainly concentrate these things. See, this lesson having the reasoning type questions. Similarly in that P block elements, you already seen that P block elements also the reasoning type question. Here also the reasoning type questions are very important in this lesson. Particularly that in-text questions are very important. Then the complete the chemical equation. Here also that reactants are given. Then you have to write the balanced chemical equation with the products. Okay, that is the complete the chemical equation. Reactant side given, you have to fill the product side. Then the order of the reactivity. Here also the order of the reactivity means that the order of the increasing the stability like oxidation state. So many things are given. That is also you have to read. Then the very important thing is the Bohr-Magneton calculation. That is a magnetic moment calculation or spin only calculation. This is a very important thing. Then after that the chemical properties and uses you have to concentrate in this lesson. Now we will see the question one by one. See, look at this question students. Why the copper 2 chloride is more stable than copper 1 chloride? That is CuCl2 is more stable than Cu2Cl2. Here already I said this copper having the +2 oxidation state and this copper having +1 oxidation state. One is this is a cupric form, this is a cuprous form. That is why more stable. This is a more stable. Copper +2 means more stable compared to the copper 1. The copper 2, usually the copper 2 is considered as a transition element and this is not considered as a transition element because of the completely filled d orbital. Here that is absence of, that is unpaired electrons are present. That is why this is more stable. The reason you have to write the CuCl2, that copper in this case +2 oxidation state, in this case +1 oxidation state because of due to high hydration enthalpy. So this is the answer. The key point is higher oxidation state in the CuCl2 compared to Cu2Cl2. Here +2, here +1, and also the due to the high hydration enthalpy. Then the second question. The atomic radii of the 4D and the 5D series elements are nearly same. Why? The reason here, the atomic, here you can simply finish with due to the lanthanoid contraction. This is the main thing, due to the lanthanoid contraction and the effective nuclear charges increases. Therefore, the atomic and ionic radii are increases from 4D to and the 5D series are nearly same. So you have to write the key point is what? Due to the lanthanoid contraction and the effective nuclear charges increases. This is the key point for this question. Then why hydrochloric acid is not used in the permanganate titration? Already we seen the titration, usually we are using that 4-normal sulfuric acid we are using. Why not we are using the hydrochloric acid? Here the question, why hydrochloric acid is not used in the permanganate titration? Here the permanganate means what? KMnO4. The KMnO4 is a strong oxidizing agent and HCl will get oxidized to chlorine. That is why we are not using the hydrochloric acid in because the permanganate, the K1O4 is a strong oxidizing agent. So it oxidized to hydrochloric acid to chlorine gas. That is why we are not using the hydrochloric acid in the permanganate titration. Then the next question is, give reason for the following. The first question is what? The transition metals forms alloys. Second is Mn2O3 is basic, whereas the Mn2O7 is acidic. Then the EU2 plus is a strong reducing agent. Why? So here the first question, the transition metals forms alloys. Why the transition metals forms alloys? See, the transition metals do not differ appreciably in their size, therefore can replace each other metallic bond and forms alloys. So I repeat this, the transition metals do not differ appreciably in their size, therefore they can replace usually each other in the metallic bond and the forms alloys. You have to write the key pointers what? Transition metal do not differ appreciably in their size. This is the main key point for this question. Then Mn2O3 is a basic, whereas the Mn2O7 is the acidic. Both are the metal oxide. See, metal oxide here, one is basic in nature, another one is acidic in nature. That is Mn2O7 is acidic in nature. Why? Here the Mn2O3. Here in this case the manganese having the +3 oxidation state. So it forms what? MnOH thrice, that is manganese hydroxide form. So on heating with water, so that's why it shows a basic in nature. Here the Mn having what? +3 oxidation state, it forms Mn, that is manganese hydroxide form. So to on heating with water, that is why this shows basic in nature. In the case of Mn2O7, acidic medium, because here look at this, here the oxidation state is higher, that is stable oxidation state, that is +7. Here +3, in this case +7. So that the higher oxidation state dissolve in water, forming like HN permanganic acid. This is MnOH, MnO4 minus, that is called permanganic acid. So that is why they are acidic in nature. I will tell you, repeat this answer. Mn here, Mn2O3 having +3 oxidation state, when react to forms what? MnOH thrice on heating with water. That is why they are basic in nature. In the case of Mn2O7, they have a +7 oxidation state in this case. That is why to form a permanganic acid, so this shows a acidic in nature. Then Europium 2+, that is EU2+, is a strong reducing agent. Why? See, the EU2+ can lose the electron to form EU3+, Europium 3+, which has a higher hydration energy. That is why it is a EU2+ is a strong reducing agent. I repeat this, EU2+ can lose one electron to form EU3+. So which has a higher hydration energy. That is why EU2+ is stronger reducing agent. See, the next question is, give reason for the following. The first question is, transition elements and their compounds act as catalyst. Second question, the E0 value for Mn2+ and Mn is negative, whereas the Cu2 plus Cu is a positive. Then the actinoids shows the irregularities in their electronic configuration. The first question, the answer is, the transition elements and their compounds act as a catalyst. Why? See, they show the transition metal shows the variable oxidation state, and they have a vacant d orbitals forming the unstable intermediate, which is readily changes into the product. So that is why the transition elements and their compound act as a catalyst. The main reason is, I repeat this, they show the variable oxidation state and they have a vacant d orbital. That is the key point. And the second question is, the E0 value for Mn2+ and Mn is negative, whereas the Cu2 plus Cu is the positive. Why? Here the Mn2+, due to the Mn2+, here the Mn2+ is a stable due to the exactly the half-filled D5 configuration, that is 3D5 configuration. They have a half-fill. Then the E naught value for the Cu2 plus, that of copper 2 plus, is a positive due to the high enthalpy of atomization and the ionization, the low hydration enthalpy. So here the half filled d orbital, that is 3d orbital, that is why it shows a negative value, and the Cu2 plus is a positive because of the low hydration enthalpy and the high enthalpy of atomization and the ionization. So that is why the E naught value Mn2 plus is negative and the Cu2 plus value is the positive. Then the actinides shows the irregularities in their electronic configuration give reason. See, most of the actinides, the compounds are radioactive elements. So they have only half-life, short life, half-life. That is why actinides shows the irregularities in their electronic configuration, and also they have a comparable energy of the 7s, 6d and the 5f orbital. That is why they shows the irregularities of the electronic configuration. I will repeat this. Many of the elements in the actinide compounds are radioactive. The radioactive elements, they have only short half-life. That is why it shows the irregularities like this electronic configuration, and also the comparable energy of 7s, 6d, 5f orbitals. That is why they shows the irregularities of the electronic configuration. Then account for the following. Next question is the account for the following. The transition metal shows variable oxidation state. Why? Here that transition metal, usually the electrons from both s and d orbitals take part in the bond formation. So example, the manganese has an outer electronic configuration as what? 3d54s2. So it shows a +2, +3, +4, +6, +7 oxidation state due to the participation of the 4d and the 3d electron. That is why they shows the highest oxidation state in the 3d series, that is +7 oxidation state. I'll repeat this. Transition metal shows variable oxidation state. Why? Because of electrons from both s and d orbitals take part in the bond formation. Okay. Then second, zinc, cadmium and mercury are soft metal. Why? What is the reason of these metals are soft? They have a weak metallic bond due to the absence of the unpaired electrons. So unpaired electrons form the additional d pi or that is a d pi bond, which is not possible to zinc, cadmium, mercury, because the zinc having completely filled orbital, cadmium and mercury also the completely filled d orbital. It is also due to the large size of their atoms due to the metallic bond is weak. I will repeat this. Zinc, cadmium and mercury are soft metal. Why? The reason is because of the weak metallic bond due to the absence of the unpaired electron, because completely paired electrons only present. Then the unpaired electrons form the d pi bond, which is not possible in the zinc, cadmium and the mercury. Okay. So this is the reason. See, look at this question. Complete the following chemical equation. See the red color, the red ink only question. I written that answer in the right hand side, that is in black in color. The red in color only question. This red in color indicates the question. Simply the questions are given like this only. Imagine this is only that question. You have to write fill the product side. First question is the 2MnO4 minus react with 5 moles of SO3 minus react with 6 moles of H plus. The H plus indicates acid, you know that. See what is the answer. See the MnO4 minus converts to, that is Mn2 plus, and the SO3 converts to SO4 minus, and this water gives a water. So here the balanced chemical already, then left hand sometimes, see I written here that 5, 8 the stoichiometric coefficient, that is not even given that question paper. Just I am writing. Why I am writing means sometimes that left hand side already the balanced chemical equation given, sometimes like the not balanced even not balanced stoichiometric coefficient, even the reactant side also. So that is why I am putting here the black color marks answer, that is means already not given that question paper. That this black colors indicates you have to balance that, even the left hand side also. Then the second question, Cr2O7, O7 2 minus, the dichromate ion react with 6 moles of the Fe2 plus ferrous 2 plus ion and 14 moles of H plus the acid to gives what? So here the 2 Cr3 plus, then 2 moles of Cr3 plus ion and 7 moles of water and 6 moles of Fe3 plus ion. Here ion converts to that's oxidizing 2 plus to 3 plus state. Then here chromium is reduced to chromium 3 plus. Here plus 6 state, here plus 3 state. And also here MnO4 minus, here plus 7 oxidation state, here plus 2 oxidation state. Then the third question. That third question, Fe2 plus, only that question paper given Fe2 plus MnO4 minus plus 8H plus gives what? See here the Fe2 plus converts to its, you can easily identify some of, like that question, Fe2 plus means given, means it converts to Fe3 plus, that means it will get oxidizes. So Fe2 plus means Fe3 plus. So then what happens? MnO4 minus, usually the MnO4 minus is here the plus 7 oxidation state. In this case, in the right hand side, plus 2. Usually it's manganese MnO4 minus reduced to Mn2 plus. So here just balance the left and right hand side. Then remaining is what? H2O. So 5 moles of 5 moles of Fe2 plus react with 1 mole of MnO4 minus plus 8H plus gives 5 moles of Fe3 plus Mn2 plus and 4 moles of H2O. The next question, MnO4 minus react with water plus iodide ion. What is the product? So complete the equation. Here 2 moles of MnO4 minus react with 1 mole of water and 1 mole of iodide ion gives 2 moles of the manganese dioxide and 2 moles of the hydroxide ion and the 1 mole of the iodic acid, that is IO3 minus. So this is the writing method of the complete the chemical equation. Usually the reactant side is given, you have to write balanced with balanced chemical equation in the product side also. So that is the complete the following equation type. In this lesson very less type only this type of question, but P block elements you have more questions in that lesson. Okay. Now we'll see some more question like calculating that spin magnetic moment also. Then different types of question we will discuss. See, look at this question. Use the data to answer the following and also justify giving reason for this question. The data are given, that is the E0 value for metal 2 plus and metal ion for the given value, like sorry, this is metal 3 plus ion, this is not a 2 plus ion, metal 3 plus. So metal 2 plus and the metal 3 plus ions are value given here. The chromium having the metal 2 plus metal is minus 0.91 volt, manganese having minus 1.18 volt and Fe having minus 0.44 volt, CO having minus 0.28 volt. Then for metal plus 3 oxidation state means minus 0.41 for chromium, Mn plus 1 plus 1.57 volt, Fe plus 0.77 volt and CO plus 1.97. So here the data are given. You have to answer this question, that is which is a stronger reducing agent in aqueous medium. Here which element is a stronger reducing agent in the aqueous medium. Here the chromium, manganese, iron and cobalt is given. See the chromium, which is the stronger reducing agent in aqueous medium means chromium. Why? What is the reason? Because the chromium 2 plus is the stronger reducing agent. It oxidizes to what? Cr3 plus. Here the Cr2 plus 2, it is the Cr2 plus 2 oxidizes to Cr3 plus. That is why stronger reducing agent in the aqueous medium is Cr, the chromium. Just you have to write the chromium is the stronger reducing agent. Because of the reason is Cr2 plus 2, Cr3 plus, which have the half-filled T2G orbital, that is T2G level is 3. I will tell you that. So chromium 3 plus mean in 3D4 the outer electronic configuration is 3D5 4s1 for chromium. Chromium 3 plus means they have 3D3. 3 electrons you have to remove, so that 3D3. That is why that half-filled T2G 3 level. So you know that coordination chemistry, based on the coordination chemistry, that is T2G level is 3 because of the 3D3 d orbital having only 3 electrons. That's why they exhibit like this, Cr3 plus. That is why the chromium is a stronger reducing agent in the aqueous medium for that given compound. Then the next question, which is the most stable ion in +2 oxidation state and why? Here the chromium exhibit +2 and manganese also exhibit +2, iron also exhibit +2, CO also exhibit +2. But which is a more stable ion in the +2 oxidation state? See, the manganese is the most stable. Second question answer is the manganese having the most stable ion in the +2 oxidation state. Why means, see, it has a half-filled orbital. The reason is half-filled orbital. For example, the manganese, the electronic configuration, outer electronic configuration is for 3D5 4s2. So in the case of Mn2 plus means 3D5. So 3D5 means half-filled. So half-filled is more stable. Here iron having +2, so +2 means 3D4 configuration like that. That is why this manganese is a more stable. That is why which is the most stable in the ion in the +2 oxidation state. Why? Because of the half-filled d orbitals. Mn2 plus is the most stable ion in the +2 oxidation state. All exhibit +2 oxidation state, but most stable is manganese in this case. Okay, so this is the answer. See, the following ions, the next question, the following ions Mn3 plus, vanadium 3 plus, chromium 3 plus and the titanium 4 plus are given. The atomic number manganese 25, vanadium 23, chromium 24 and titanium is 22. The question is, which ion is most stable in aqueous solution? Then which ion is the strongest oxidizing agent? Then which ion is the colorless? And which ion has the highest number of the unpaired electron? So here the atomic number is given also. So that already you know that which ion is the most stable in aqueous solution means chromium 3 plus. Here the chromium 3 plus is the most stable ion in the aqueous solution. Then because already you know that there is they have a T2G3 level. Okay, the energy is T2G3, that is why chromium 3 plus in aqueous state usually acidic in nature, that is why most stable in the aqueous solution. Then the second question, this is the first question answer, the Cr3 plus is the most stable ion in the aqueous solution. Second question, which ion is the strongest oxidizing agent? You can tell this is the manganese 3 plus. The second answer is Mn3 plus. See here the manganese 3 plus is the more stable strongest oxidizing agent. Then due to the higher oxidation state, they exhibit the +7 up to +7 oxidation state. That is why and that E0 values also. That is why they are strongest oxidizing agent. Then which ion is the colorless? Third is the which ion is the colorless? Out of this 4, the titanium 4 plus is the colorless. The third answer is titanium 4 plus is the colorless, because there are no unpaired electrons. There are no unpaired electrons present in the titanium ion because of the titanium, given the oxidation number, atomic number is 22, then the electronic configuration is what? 3d2 4s2. So titanium 4 plus means it will become 3d0. So no electrons present in the d orbital, that means no unpaired electrons present. That is why titanium 4 plus is the colorless element. Then which ion has the highest number of the unpaired electron? In this case, the Mn3 plus. The Mn3 plus, the fourth answer is Mn3 plus is the highest number of the unpaired electron. For evidence, the manganese having 25. The atomic number is 25. So the electronic configuration is 3d5 4s2. But this is the outer electronic configuration for the manganese. Here the Mn3 plus means the removal of the 3 electron, it will become 3d4. So 3d4 means what? 4 unpaired electrons are present. So 4 unpaired electrons are present. So that's why Mn3 plus is the highest, that is highest number of unpaired electron in this given element. So vanadium 3 plus, you can check it that vanadium 3 plus atomic number is 23, so that you can cross check it 3d3 4s2. So 3d3 4s2, vanadium 3 plus mean it will give 3d2. Then chromium, you know that the chromium also 3d3. They have 3d3. Titanium 3d0, already you know that. So here in the case of manganese only, it exhibits 3d4. That is why highest number of the unpaired electron present in the Mn3 plus ion. So the first question answer is which ion is the most stable in the aqueous solutions? Mean chromium 3 plus because of the T2G 3 level. Then next question is which ion is the strongest oxidizing agent? The strongest oxidizing agent is Mn3 plus. Then due to the electrode potential value. Then which ion is the colorless? The colorless is titanium 4 plus ion is the colorless. Then which ion has the highest number of unpaired electrons? Mean Mn3 plus. So this is the answer. The next question is calculate the magnetic moment of a divalent ion in aqueous medium if it is the atomic number is 26. So the atomic number 26 mean it compound, that element must be iron. So iron having the atomic number 26. Okay. Now the writing of the electronic configuration for outer electronic configuration, iron is 3d6 4s2. Iron having the 3d6 4s2. The iron usually exhibit the two state. One is Fe2 plus, another one is Fe3 plus state. So in this case, here the divalent ion in the aqueous solution, the magnetic moment of the divalent ion, so that having the Fe2 plus state. It means the Fe2 plus because of the divalent ion. So Fe2 plus means the oxidation, the electronic configuration will be 3d6 4s0. So simply D6 system, it under the D6 system. So writing of the 3d orbitals. So having 6 electrons, so 1, 2, 3, 4, 5, 6. Count the number of unpaired electron in this system. See here the number of unpaired electron 1, 2, 3, 4. So number of unpaired electron is 4. That is called N. Simply they are called N. So N is equal to 4. You know that Bohr magneton formula is the spin only magnetic moment calculation is mu is equal to root of N into N plus 2. Here N value is what? That is the N value indicates number of unpaired electrons. So that the number of unpaired electron is 4. So 4 into 4 plus 2, it will become 24. So 24, root 24 means what is the value of root 24? That will become 4 point something value. So 4.92 Bohr magneton. This is the unit. 4.92. You have to show that the unit, this is Bohr-Magneton value. Mu is equal to 4.92 Bohr-Magneton. First, you have to see in the calculation of the magnetic moment, you have to look at the unpaired electron. Whatever the given atomic number, just look at the unpaired electron. Okay. So, in the case of suppose if there is the atomic number is 25. Suppose in case given 25 means what happens? The 25 means manganese. So, manganese having the 25. So, the divalent is Mn2 plus, the most stable oxidation state, Mn2 plus, that's mean 3d5 4s2. So, Mn2 plus means removal of the 2 electron, 3d5. So, 3d5 means the number of unpaired electrons, the d orbital, 5 unpaired electrons, the d orbital. Okay. Similarly, you have to apply that n value in this formula. You will get that the mu value. This is the calculation of the Bohr spin only magnetic moment. See, the next question is, and adding NaOH, sodium hydroxide, to ammonium sulfate solution, a colorless gas with pungent odor is evolved which forms a blue colored complex with Cu2 plus ion. Identify the gas. So, you have to identify the gas. So, the pungent smell, the ammonium sulfate and adding of sodium hydroxide solution and heating, it converts to what? The ammonia gas. See, the evaluation of the ammonia gas, usually the ammonia gas having the pungent smell. So, again it's converts to the byproduct is sodium sulfate. Again, that gas react with the Cu2 plus ion. The question is what? The pungent odor is evolved which is forms a blue colored complex with the Cu2 plus ion. So, here the Cu2 plus ion is copper sulfate. So, that copper sulfate react with the ammonia gas to forms a complex, that is a blue color complex. So, here identify the gas. So, here the ammonia is the gas. The answer is ammonia gas. See, look at this question, the compound identification type question. When chromite ore FeCr2O4 is fused with sodium hydroxide in the presence of air, a yellow colored compound A is obtained, which on acidification with dilute sulfuric acid gives compound B. Then the compound B on reaction with potassium chloride forms an orange colored crystalline compound C. Here write the formula of the compound A, B and C, then write one use of the compound C. So, this is the question. See, here when chromite ore, this is the chromite ore, treatment with fused with that sodium hydroxide in the presence of air to gives yellow colored compound A. So, that is, this is A gives the yellow colored compound. This is sodium chromate. The sodium chromate, this the A is obtained, that which on acidification. So, the A undergoes an acidification, that is acidification means sulfuric acid, treatment with sulfuric acid, dilute sulfuric acid gives compound B. So, this is the compound B, that is sodium dichromate. The compound B is orange color. So, orange color. So, the reaction with the compound B on reaction with KCl forms an orange colored crystalline compound C is formed. So, here sorry, this is not a color, the sodium chromate, the sodium dichromate react with potassium chloride, the compound C is formed. This is the orange color crystalline compound C. So, this is the orange color crystalline compound C. Here the question, write the formula of the compound A, B and C. So, compound A is Na2CrO4 and the compound B is Na2Cr2O7, this sodium chromate and sodium dichromate. Then compound C is potassium dichromate. Then the answer, the next question is, answer is write one use of the compound C. So the compound C is the oxidizing agent. C is the oxidizing agent, and which is act as a primary standard in the volumetric titration. So this is the answer, the compound identification types in the inorganic chemistry. See, the next question is, why is zinc not regarded as a transition element? Then the copper atom has completely filled d orbitals in ground state, but it is a transition element. Why? Then zinc 2 plus salts are white while Cu2 plus salts are colored. Why? What is the reason? The first question, we'll see the answer. The first question, that why is the zinc not regarded as a transition element? See, the zinc atomic number is what? Zinc having 30. The atomic number is 30. So the outer electronic configuration is what? 3d10 4s2. So the d orbital, write the electrons for a d orbital. So 10 electrons in the d orbital, 3d10. Then zinc 2 plus. Zinc 2 plus means the electronic configuration is 3d10 4s0. So here also the same, the completely filled electrons. So when the transition metals mean at least one unpaired electron should be present. Otherwise, this is not considered as a transition element. So the zinc, neither zinc nor zinc 2 plus, it is not considered as a transition metal because the d orbitals are completely filled electron. So that is why there is no presence of unpaired electron. That is why zinc or zinc 2 plus not regarded as a transition element. Then the second question, copper atom has completely filled d orbitals in the ground state, but it is a transition element. Why? See, what is the look at here, this is 30. The copper, for example, the copper is atomic number is 29. So the electronic configuration is what? 3d10 4s1. So this is for copper. Here also 3d10. But the copper atom has completely filled d orbital in the ground state. So in the ground state, look at, this is the ground state. So completely filled d orbital. But it is a transition element. Why? See, the copper exhibit here, zinc exhibit 2 plus state. In the case of the copper also exhibit plus 2. The plus 2 means removal of 2 electrons mean it will become what? 3d9. So presence of one unpaired electron. That is why copper 2 plus considered as a transition element. In case of Cu plus means, for example, Cu plus, it will become 3d10. This is not considered as a transition element because of the completely filled d orbital. There is no unpaired electron. So only Cu2 plus considered as a transition element. The zinc 2 plus does not consider as a transition element. Reason is completely filled d orbital. Here the Cu2 plus having presence of one unpaired electron. That is why it is considered as a transition metal. So the first question answer, zinc is not regarded as a transition element because of the completely filled d orbitals. That is the answer. Then the copper atom has completely filled d orbitals in the ground state, but it is a transition element. Why? The reason is because of presence of unpaired electrons in the 3d9 configuration. That is why this. But in the case of Cu plus, it is not considered as a transition element. This is not considered as a transition element, but the 3d9 Cu2 plus considered as a transition metal. Then the third question, zinc 2 plus salts are white while Cu2 plus salts are colored. What is the reason? So zinc 2 plus, you know that the zinc 2 plus, there is no unpaired electrons are present. But Cu2 plus, look at the Cu2 plus presence of one unpaired electron. The compound simply presence of unpaired electron in the d orbitals mean the compound usually colored in nature. Okay, completely filled or empty orbital, its compounds are colorless or white color substance, that is white in color substance. That is why this is the reason. And you can tell that is DD transitions are occur. So zinc 2 plus salts are white, while Cu2 plus salts are colored, means presence of unpaired electron or DD transition occurs. DD transition occurs. So this is the answer. Hi students, today we were seeing the different types of the reasoning question, then account for the following types of question we were seeing. Then after that, the complete the chemical equation, that is the balanced equation, how to write, that is also we were seeing in this chapter. Then the calculation, magnetic moment calculation, then reasoning types of questions also we were seen in this video. Just go through this video clearly, then we'll get a more mark in this lesson.